Hello students, this is Sir Shakil, Physics A-level teacher, and today we are going to discuss CAIE AS Physics 9702 and its Unit 2, and the chapter is Kinematics. And in Kinematics, we have to study the topic Projectile Motion. So this is point number 9. We have to describe and explain motion due to uniform velocity in one direction and uniform acceleration in a perpendicular direction. Okay, before we go into the topic, we have to understand what is the projectile motion. If you look at the first diagram, there is a footballer. He's going to kick the football, and the trajectory of the football is shown in the diagram. Trajectory is the path followed by the football. So as you can see that the football is moving along a curved track in air before landing on the ground. So this motion of the football in air, which is along the curved track, is known as projectile motion. Similarly, if someone is throwing a ball or any object in air that is moving along a curved track and then it is landing on the ground. So this motion of object is also known as projectile motion. Similarly, if you are playing a basketball and you have to throw the ball in the basket, so the ball is moving along a curved track before turning into the basket. So its motion is also projectile motion. In the next example, there is a cannon placed at some high altitude from the ground. Let's say this is the ground and it is placed at a high altitude. So if we fire the shell from the cannon, and let's say if there is no gravity over there, then it would be moving along the straight path. But we know that this is not possible because gravity is everywhere. So it means that when you fire it horizontally, instead of just going straight or instead of just falling down, it will be moving along a curved track before hitting the ground. So its motion is known as projectile motion. Let me show you some simulations for this. Okay, here is a cannon and we are going to fire it. So first of all, I am firing it vertical. So look at the movement. The ball is moving straight and coming down. So its motion is vertical motion. Again, the ball is going up and coming down. So it is vertical motion. Now, if we consider it again, okay, let's fire it. It's going up, coming down, going up, coming down. So this is vertical motion. Now, if we inclined it at some angle, and that angle is 75 degree, and we fire it, so see, it's falling here. Again, falling here. In the slow motion, just keep an eye on two green arrows with the shell. See at the highest point, and then coming down. Okay, so these two green arrows actually represent two components of the velocity. The component which is along horizontal axis is horizontal component, and you can see that its length remains the same. And the component which is in vertical direction, it is vertical component of velocity, and see its value changes. At highest point, it is 0. Its direction is turned down and its value is increasing. Now let me decrease the angle further and fire it. So see what's happening is the projectile is moving with the same speed of 18 meters per second. It is like initial speed is 18 and it traveled a further distance. Okay, now I am shifting it to 45 degree and firing it. So it is moving further. And when I decrease the angle to any other value, it would fall short of. Okay, so all these movements are in air and they are along the curved track. So all these movements are known as projectile movement. Only this movement is vertical movement and all other are along the curved track. So those are known as projectile motion. Okay, now let's get back to the definition. So let's define it. Projectile motion is the two-dimension motion of object in air due to gravitational effects. Or we can also define it, the motion of object due to two components of velocity is known as projectile motion. Remember, two components. Or we can also define it as motion of object along a curved track in air. It is known as projectile motion. Now, as projectile motion is a type of motion, so it is having some terms related to it. So what are the terms? The first term is velocity, the horizontal component of velocity and vertical component of velocity. The second one is maximum height gained. The third one is time to reach maximum height. The fourth one is time of flight. Time of flight means how much time it spent in air. Number 5 is range, how much horizontal distance it has moved. And number 6, the acceleration or the gravitational acceleration and its horizontal and vertical components. So we have to study these terms. Over here in the diagram, this blue arrow is actually representing the total velocity. The green arrow is the vertical component and the red arrow is the horizontal component of the velocity. And then the maximum height, this one is the maximum height gained by the projectile. And then for the range, it is the horizontal distance between the landing point and the projection point. So these are the terms that we have to study. Now, as we know that this projectile motion is uniform accelerated motion because it is happening due to acceleration of gravity, which is 9.81. And interesting thing is that this acceleration due to gravity is remaining same throughout this motion. That is like 9.81 meter per second. So that's why we have to use equations of motion to solve all these terms. So we can say that as acceleration during projectile motion remains constant, that is plus minus 9.81 meter per second square. So we will be using equations of motion or Survey equations to find terms related to it. And you know, equations of motion consist of 5 terms: initial velocity, final velocity, acceleration, displacement, and time. So for initial velocity, we'll be using horizontal component as ux or uh, and then the vertical component as uy or uv. And for the final velocity, it is vx or vy, the two components, or they can also be written as vh or vv. And then acceleration can be replaced by plus g if the object is moving downward, if the object is initially thrown downward, and it is replaced with minus g if the object is thrown upward. And the displacement is replaced with height, and there is no substitution for time as it is same for both linear and curved motion. Okay, let's study these terms one by one. The first term is velocity. Okay, so the projected velocity at any angle with ground or horizontal axis is always having 2 components. So let's say this in the diagram, u is the projected velocity between x and y axis. So when we have to resolve it, so it will be resolved in 2 components. The first component will be along x-axis, and that is known as UH or UX. And the second component will be along y-axis, so it will be UY or it will be UV. So it means any projected velocity at some angle with the ground is having 2 components, horizontal component and vertical component. As in vectors, we are already aware that this UH is adjacent to angle, So its value, it is written as UH or UX, and its value is U cos theta. So what is the feature of this U cos theta? It remains same throughout the projectile motion, as no opposing force for it or no gravity is affecting it. So it means that its value will remain the same at all the points during the projectile motion. Okay, the second one is the vertical component of the velocity. It is denoted by Uy or Uv, and it is equal to U sine theta, and this is at the start of the motion. Now, what is its feature? As this component is parallel to gravity, so it is affected by the gravity. That is, in upward motion, it decreases, and in downward motion, it increases. And the values, its value is maximum, its value is minimum at the maximum height. It means the horizontal component of velocity is not changing, it is remaining the same, but vertical component, when the object is moving up, it is decreasing, and when the object is moving down, it is increasing. I'm again taking you to the simulation where you can see this effect clearly. Okay, so let's move on to this. And again, you can see from here that what's going to happen is, just keep an eye on the two components of the velocity, the horizontal and vertical. See, the horizontal arrow is same. It is not changing. It is not changing. But look at the vertical one. The vertical one is maximum at first. At highest point, it is 0. And then it is increasing, 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 increasing. Again, relook. So these are the two components of velocity I talked about. So horizontal component is always same, but the vertical component is changing. Why? Because gravity is vertical, so it is affecting its motion. Okay, now let's get back to this, and let me redraw it over here for you. This is the object, and let's say it is projected with a velocity u at an angle theta, and it reaches at this point. Okay, at this point, its horizontal at the start, its horizontal component is like this UH, and this is the vertical component. Okay, so both are having like the maximum value at the start. Over here, at this point, the horizontal component will be same, but the vertical component will be decreasing, and it is now Vy. And when it reaches the next point, here and then at the highest point. So at this point, the horizontal component is remaining the same and the vertical component is decreasing. At highest point, the horizontal component is same, but vertical component is 0 at the highest point, because like this is here, highest point. So at maximum height, the vertical component is 0. When it is moving down, then what's happening is, when it is moving down and down like this, so what happens to the components? The horizontal component remain unaffected. Its value will remain same at all the points. Its value is not changing. Why its value is not changing? Because gravity is acting down. Like the gravity is acting down, and gravity is perpendicular to horizontal component. That's why horizontal component is unaffected. But if we talk about the vertical component, then it will start increasing. It reverses its direction and it will start increasing again. So that's how this works, because the vertical component is parallel to gravity. That's why its value keep on changing. Now, as the horizontal component remains same, so you can find its value as u cos theta, right? Where u is the projected velocity, like the velocity projected net or total velocity with which you are projecting it. And theta is the angle. So theta is the angle with the x-axis. So UH will remain the same. Now the question comes for UY, the vertical component of velocity. So let me tell you about that. vertical component of velocity. So vertical component of the velocity, for that, I'm going to draw two situations. In the first situation, the object is going to be projected from ground and it is landing on the ground. For second, it is going to be projected from here and then it is leaning towards the ground. So for the first situation, it is projected with u at an angle of theta. So the vertical component will be maximum at the start. So we say that at start, the vertical component is maximum. And then at the highest point, when it reaches at the highest point, the maximum height, at maximum height, it is 0. So at maximum height, the vertical component is 0. And then next thing is that it switches its direction once crosses the highest point and its value keeps on increasing. Okay, so near the ground, its value is maximum. So near ground, vertical component is always maximum. Okay, in this situation, when you launch it from some height from the ground with a velocity u, then its initial vertical component is 0 because it is moving horizontally. So that's why initial vertical component is 0. But as time will pass and ball will move forward, its vertical component will keep on increasing. And it will be again maximum near the ground. As I told you that it is maximum near the ground. And at highest point, in both the situation, like this is the highest point and this is the highest point. So at highest point in both the situation, the vertical component is 0. Okay. Now we can do one thing. If we have to find the value for both of these situations, so let's say we can say that for this diagram, at start uy is u sine theta, right? And over here at start in this situation, at start uy is 0. So these are the two things. Okay, now if you want to find the vertical velocity at any point once the motion is started, let's say you have to find vertical over here, find vertical component of velocity, or you have to find over here, find vertical component of velocity. And of course, they will give you some time that at this time, the object reaches at this point. So you have to find vertical component of velocity. So how to find that? So we say that finding vertical component of velocity. Okay, as we know that the acceleration is constant, which is plus minus 9.81 meter per second square. So we are going to use equations of motion. So for these cases, we have to, usually we use V equal U plus AT. So this is the equation that we are going to use. Okay, so now we have to modify it in terms of projectile motion. So this V is actually Vy, this U is actually Uy, and this A can be plus minus G, depending upon how you are throwing it. If you're throwing it upward, then G would be negative. If you're throwing downward, G would be negative. So this is the equation that you are going to use in order to find vertical component of velocity at any point during the projectile motion. So Uy is like actually U sine theta and plus minus GT. So using this, you can find vertical component of velocity at any point. So let's say if this is the ground and a projectile is being projected from here with initial velocity u and theta angle, and it is moving like this. And after some time at this, you have to find its vertical component. So this u is the initial velocity, which is given. This theta is this angle, which is given. And this t is this time, which is given. And over here, you will use g as minus 9.81 meter per second square, as initially its direction is upward. So using these values and this equation, you can find vertical component of velocity. The next thing is finding total or net velocity at any point. If you want to find the total or net velocity at any point, how you can find that. And again, I have to draw the diagram for you. It's like object is throwing from here and it's moving along this way and falling on the ground. And let's say at any point, you have to find what is the total velocity. This point can be any point. Let's say it can be the start point. You have to find the total velocity, provided you already know the horizontal component and the vertical component. Or at highest point, you have to find how much is the total velocity, or at landing, you have to find the total velocity. So how to find that velocity? So there are two methods for that. So method one is triangle method. And you will be using this triangle method if both the horizontal and vertical components are known to you. If you know both the components, then you're going to use triangle method. For example, at the start, if we talk about the start, then you already know that this is UH, you know its value, and this is UV, or the vertical component, you know its value, and then you have to find this velocity U. So what you'll be doing is, you will be arranging them according to head to tail rule, like this is UH, and this is UV, and then finally, the total velocity will be this, which you have to find. So as this is right angle triangle, so you will be using Pythagoras theorem for it. And that will be like U equal UH square plus UV square whole square root. So this will give you the total velocity. The same process can be applied anywhere at any path during the projectile motion. Like you need to know horizontal component, you need to know vertical component, and in order to know the vertical component, you'll be doing this. So this will help you to find the vertical component, like the first equation of motion, and then using Pythagoras theorem. Okay, let's talk about the method two. Method two is again, it is angle or trigonometric ratio method. Trigonometric ratio method. And for that, let's say that an object is projected from here and it is coming on the ground. And for example, over here, you have to find its total velocity. But one thing is given to you, which is like this is the horizontal line, and the angle of this total velocity, with horizontal line is given to you, and initial velocity is given and the angle is also given. So what you will do is, from the start, you know that UH is given and that UH will remain same everywhere. So you know the UH value, which will be parallel to the line. So you will be again making a vector triangle. So now make a vector triangle in which you will draw UH first, and then of course, Vy, or the vertical component, is there. You don't know its value, but you can draw it. And then this is the resultant velocity which you have to find. Again, this angle is given. So this angle will be over here. So this will be known angle. So as this vertical is not known, but horizontal component is known, which is sine theta, u cos theta, you can find that. And you have to find V, and angle is 90 degree and one angle is given. So as one side and one angle is given, so you can use trigonometric ratio. So it's like you can use cos theta equal UH over V, right? So then you can use V equal UH divided by cos theta. So this will give you the total velocity at that point. So these are the two methods. The first method in which you know both of them, like you know UH, you know vertical and horizontal, both are known to you, and as they're right angles, so you use Pythagoras theorem. In the second method, you know the angle, but you don't know vertical component. So that's why, as the triangle would be still right angles, so you can use trigonometric ratio to find the velocity. So this was the first thing, the velocity. Now let's move on to second thing. And the second thing is over here, it is time to reach maximum height. Time to reach maximum height. Okay, as you know that when projectile is projected from ground in upward direction, it moved and it covered a maximum height as it is moving along vertical axis as well and along horizontal axis as well. So for the vertical axis, how much is the maximum height gained by the projectile? So for this, you need to use vertical component of velocity. So vertical components of velocities are used because vertical component is along y-axis and height is also along y-axis. That's why we use that. Okay, now we have to use equation of motion. But for that, to decide which equation we're going to use, we have to pick the data. So if we pick the data from here, we know if u and theta are given, then we know uy, and at maximum height, we know that the vertical component is 0, and as it is projected upward, so g is minus 9.81. So we say that uy is like u sine theta, we know this. Vy is 0 at the maximum height. We know that at maximum height it is 0. And then the acceleration is minus 9.81, which is known, and you have to find S or H. So in this, time is missing, like the time is not given. So you will select an equation in which time is not there. So we will be using 2as equal v square minus u square. Now, once the equation is decided, you have to modify it. So let's modify it to a is minus g because object is moving up, and s is h, and this is vy square minus uy square. So now let's just quickly solve it. Vy will be 0 because at maximum height it is 0, and then uy is actually u sine theta square. So this negative will goes away. So making h as the subject, it will be u square sine square theta by 2g. So this is actually the height expression. Okay, so what we have to do is over here, it is actually maximum height. So this is actually maximum height. This is not time, this is maximum height. So how to find maximum height? So we use vertical component. All other things are fine. Okay, so this was the expression for maximum height. And now, number 3, we have to find time to reach maximum height. Time to reach maximum height. So how much time the projectile will take to reach the maximum height? And again, we'll be using vertical component. So vertical components of velocities are used. So it's the same case as the previous one, like this one. So we have to pick the data. So what is the data? The data is like uy is given, which is u sine theta. And then a is also given, which is minus g. And the final vertical at maximum height is 0. And what you have to find is t. And let's say s, the height can be missing or it can be given. Like missing or given, whatever. So which equation you can use? Let's say if S is missing, or let's just leave that, what equation we will use? V is U plus AT. And now you have to modify it. So it will be like dy is uy minus gt. As it is moving upward, that's why minus gt. So you know that at maximum height, Vy is 0, Uy is U sine theta minus Gt, and then it is Gt is U sine theta, and then T is U sine theta over T. So you can use, sorry, it's G. So you can use this equation to find the time to reach maximum height. Number 4 is total time, or it is time of flight. Okay, so time of flight matters for 2 cases. Like first case is this one, and second case is this one. Okay, for the first case, the time of flight is 2 into time to reach maximum height, because it reaches in small t time to maximum height and it takes the same time to reach the ground. So it means that you'll be multiplying 2 with time to reach maximum height to get time of flight. But over here, your time of flight is actually equal to t, because the ball is already started its motion from the maximum height. So time to reach maximum height is actually time of flight. And you know the time to reach maximum height is u sine theta over g. That's all you can calculate it. Okay, the next term number 5 is range. And this range is known as horizontal distance as well. So it means that we have to tell that how much horizontal distance an object can cover. So let's say if it is launched from here with angle theta, with u and angle theta, so it is moving up and it is landing on the ground over here. So this is your start point and this is your stop point, start and stop. So this is known as range, the distance between start and stop. So this distance, this range is actually dependent upon horizontal component of the velocity. So as horizontal component is remaining same everywhere, even at the highest point, so that's why we will be using V equal d by t. So as horizontal component is constant, it is not changing, and horizontal acceleration is 0 because horizontal component of velocity is not changing. That's why we will be using V equal d by t. And then modifying it, V is like UH and D is actually range and small t is time of flight. So we can say that this range is equal to UH into T, or this range, which is horizontal distance, is U cos theta into T. So this is the equation you can use to find the range. Okay, moving to the next topic. After number 5, number 6 is distance and displacement. Okay, so let's say that a projectile is launched from here with a speed u. Of course, it will be moving along curved track while falling on the ground. So this is the range or the distance
horizontal distance that it has covered. And this S is, let's say, the height of the projectile between 2 points. So if we want to show the displacement of projectile, displacement is the shortest distance between start and stop point. So as we know that this is the start point and this is the stop point. So the shortest distance between these two will be along the straight line like this. And this will be the displacement. So if you want to find the displacement, so then this displacement can be determined using Pythagoras theorem. Okay, why Pythagoras theorem? Because this range is known and this height is known. So this is a right angle triangle. So you can find the displacement. So this displacement is equal to height square plus range square whole square root. So you can find this displacement easily. Okay, number 7. Number 7 is time variation with other quantities like speed. So like if we vary the speed of the projectile, in the initial speed, if we throw the projectile at different speeds, then how the time will be affected. So we can look for the simulation over here. If you can see over here that what we are going to do is we are going to throw it with a speed of, let's say, 10 meters per second. And we have to see that how much time it will take to reach the ground. And if we see, it took 1.56 seconds. You can see, as you can see over here, it is 1.56 seconds if you throw it with 10 meters per second, right? Okay, if we increase the speed to, let's say, if we double it, 20 meters per second, and let's just throw it again. So let's see, the initial time is like 1.56 with the speed of 10. And now if you can see for this, the time is 2.73. So again, for the speed of 20 meters per second, it took 2.73 seconds to land and range is 20. But if you throw it with 10 meters per second, it took 1.56 seconds and the range is 7.72. So we can conclude one thing, that if you throw something up with speed u, okay, so let's say I'm throwing it and it's going like this. And now if I throw with a speed that is more than this, but I keep the angle same, so it will be falling out over here. So the red one is having a speed of 2u, or you can say 3u, and this black one is having a speed of u, and they have same angle. So it means that when you throw with higher speed, then its time in air will be increased. So we can say that time is proportional to your initial speed. And secondly, the range is also proportional to initial speed. And the third thing is height. So the height is also proportional to your initial speed. So if you increase initial speed, time will be increasing. If you increase initial speed, the range will be increasing. If you increase initial speed, the height gained by projectile is also increasing. But if we consider this, in this case, let's say the projectile is going to be projected from this point horizontally, like it is horizontally, but of course it is going to come down. And let's say if we throw it with a double speed, it will move like this. So this is with initial speed of, let's say, 2u, and the first one is with initial speed of u. So what's the difference? The angle is still 0 over here, but what will happen if you increase the speed? The range will increase, of course, as you can see that the range 2 is like this one, and the range 1 is like this one, but they are at the same height. So we say that if the range in this case is proportional to speed, if you increase speed, the range will increase. But surprisingly, there is no effect on time. No effect on time. Both the projectile, even if you throw them with higher speed or lower speed, like with one with u and one with 2u, there would be no difference in time. And what is the reason for that? Because in order to find the time in this case, we use the equation s equal ut plus half at square. Why we use this equation? This is a big question mark, because when you look at the data, you know s, right? And then let's say, you know the gravitational acceleration, which is plus g. So you already know this. So you know acceleration, you know s. And as in time, we use vertical component, you know? So we use vertical component in time. Vertical component of velocity is used to find the time. And you know over here, uy is 0. Like it is projected with u, but the vertical component is 0 because it is moving horizontally. So that's why we say that, okay, we have also the value of u and you need to find t. So replacing all the values, s is h, and this u is cancelled because it is 0, uy is 0, this is actually uy, and then it is half gt square. So from here, t square will be 2g by h, or you can take square root to eliminate this. So from here, we can say this is actually 2h over g. So from here, from this expression, we can say that time is independent of the initial speed in this case. Time only depends upon two things. The first thing is height, and second thing is g. So as you are throwing both the objects from the same height, like this one and this one from same height, and gravity is same, that's why both the objects will be falling down, taking the same time. The last and final thing is, if you drop an object, if you have two objects and they are at the same level, like object A and object B, and let's say this is ground, and if you drop them from at the same instant, like if you just drop this A, it is coming down, like A is dropped, right? A is dropped. And you throw B with some speed, so obviously B will take projectile motion and projectile path to reach over here. So the time for A to reach ground and time for B to reach ground will exactly be same. Exactly be same. Why? Because gravity is acting vertically downward and it is affecting both the objects equally. So as object A was having 0 speed and its speeds keep on increasing, but B was already thrown with some speed, and as it moves down, its speed further increases. B has to cover, of course, more distance, but as its speed is more, that's why it will take the same time. So in this motion, A and B took same time to reach the ground. Now, what you have to do is, I'm going to share an example over here. And what you will be doing is, you will be solving it, and the answers, I will share the link in the description of the video. So let's say an object is over here and it is projected with a speed of 30 meters per second at an angle of 40 degrees. And of course, it takes this path before it lands on the ground. And there are some points, like these are the 2 points, like this is the projection point P, this is Q, this is R, and this is S. So what you have to do is find number one, horizontal component and vertical component of velocities at point P, Q, and R. And at R, time to reach there is 1.2 seconds. Like at R, the object reaches at 1.2 seconds. So at 3 points, you have to find horizontal and vertical component of velocities. Okay, then you have to find total velocity at R. How much is the total velocity at R? Number 3, you have to find maximum height gained. How much is the maximum height gained by this projectile? Number 4, you have to find time of flight, how much total time the projectile took to travel between these 2 points. Number 5, you have to find the range, and range is the horizontal distance, like how much distance it has moved. So the answers will be shared in the description. So I hope things are clear to you. If you're having some trouble in understanding any concept, you can always use the comment box to enter your query, and I will try my best to answer that. And I'm also going to share a practice worksheet in the description link. Thank you so much. I hope you have enjoyed the time. See you again with the next video of graphical analysis of motion in kinematics.